I used this term before and I'm defining it with the help of the figure. This is angle of friction. I've used the symbol lambda for this, as you can see here. So the angle of friction between a given pair of surfaces is the angle between the total contact force and the normal force at the instant when the surface is just about to slide over another. That we have seen here. We have drawn many similar situations a short while ago and I called it the angle alpha. But this last case I have drawn in front of you, this is the case where the frictional force is equal to the limiting friction, and in that case angle, the R max, total contact force mixed with the vertical, is known as the angle of friction. Let us find this value lambda in terms of mu s, the friction coefficient between the block and the floor. To find the angle of friction lambda, we shall refer to the triangle OBC. As you can see in the figure, I have called OC as the arrow that represents R max, total contact force. In the triangle OBC, you can see that tan of angle BOC, you can apply a little bit of trigonometry here, simple stuff. That is given by BC perpendicular divided by the base, and that is OB. This is giving me tan of lambda, because angle BOC is lambda only. BC is equal to Fs max. BC represents the magnitude of Fs max. So we can write down this is Fs max, force of limiting friction, divided by OB. OB is nothing but the normal force magnitude. But again we know Fs max is given by the law of static friction. The first law says Fs max is equal to mu s. Static friction coefficient is called mu s multiplied by normal force, mu s into n, divide by n cancel out, and we are getting this is coming out to be mu s. So we have arrived at a very important result. That result is, if lambda is the angle of friction between two surfaces, between two blocks, tan lambda is equal to mu s. Or you could write down, if you feel like, lambda is equal to tan inverse mu s. There are two different ways of writing the same result. Tan lambda is equal to mu s, or lambda is equal to tan inverse of mu s. We shall highlight this result. So the result that we find here and highlighted, as you can see on the screen, that tan lambda is equal to mu s, that tells us the tangent of the angle of friction is equal to the static frictional coefficient, and that we call equation number 3. This is very interesting because if you remember well, you have seen earlier that we also got equation number 1. Let me write it here briefly. You have got angle of repose, tan theta s. This was also equal to mu s between two bodies, or two surfaces. So here we see that between any two given surfaces, angle of repose and angle of friction, they are both equal and their tangents are equal to the static frictional coefficient. As a reminder, let me tell you, angle of repose theta s is the minimum inclination of a plane on which a body begins to slide down under its own weight, and lambda, as we have just now learned, angle of friction is the angle made by total contact force with the vertical in the extreme or limiting case when the body is just about to move under an external propulsive force. Let us go further. This was, of course, equation number 1, and I'm just writing it here for easy reference, and you can compare them and see that theta s and lambda are equal. So let's go further with this calculation and find out the value of R max. In the same triangle, you can see OBC, OC square that is the hypotenuse in the triangle, because this angle is of course 90 degree. OC square is equal to OB square plus BC square. Now this means OC is of course the magnitude of R max. So I'm getting R max square is equal to OB. OB is the magnitude of N, normal force, N square plus BC square. Now BC is same as OA. Yes, BC and OA, they are equal in length because they are the opposite sides of a parallelogram or rectangle in this case. So BC is same as OA, and that is equal to Fs max. So N square plus Fs max of course is the limiting frictional force, Fs max square. Writing further, we can write this is N square, recalling the fact that Fs max is nothing but mu s into N. So writing Fs max as mu s into N whole square, where mu s is the static frictional coefficient. You can eventually show that the value of R max, the total contact force maximum value, is equal to normal force multiplied by square root of mu s square plus 1. This is another important result, and we shall highlight it as well. So have a look at my fourth important result kept inside this red box. R max is equal to N into square root of mu s square plus 1, where R max is the value of maximum value of total contact force exerted by the ground onto the block. This is this R max, total contact force, which is resultant of normal force and limiting frictional force. And that force can be shown to be equal to normal force multiplied by square root of mu s square plus 1, where mu s is the static frictional coefficient between the block and the ground. That's the fourth and last important result. We shall end this topic by just mentioning one more term, which is called cone of friction. Let me write the term here. This term is cone of friction. Now what is a cone of friction? I wish to write the term somewhere so that you can follow it properly. This is called cone
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.